Okay, so we're looking at these problems, and we have this twice differentiable function where f2 equals 5 and f of 5 equals 2. Let g be the function given by g of x equals f of x. That's kind of interesting. Explain why there must be a value c for between 2 and 5 such as the derivative at c is -1. Okay, so let's look at this one. Usually when they're talking about a c in between a value and f prime of c, we're thinking of mean value theorem. So let's apply the mean value theorem, or let's see at first if it actually holds. Mean value theorem, can we use the mean value theorem? Let's see. We have the endpoints, which is 2 and 5, found right here and here. Are they continuous? I mean, is it differentiable and continuous throughout this interval? It is, because it said it right here. Twice differentiable means we can apply the mean value theorem because it's differentiable. So those two conditions hold. Let me just, I guess, be more specific on what I mean by differentiable along this, because it is a twice differentiable function. So we can use it in part A. So part A. Let's find the average rate of change. So f of 5 minus f of 2 divided by 5 minus 2. Notice that this is, we have to basically only look at these values. We're not looking at the result, because that gets confusing for a lot of people. They might accidentally use 5 and 2, but you have to use the value at 5 and the value at 2, and then divide by these values, or the subtraction of these values, the rise over run. So this is, in fact, what is this? 2 minus 5 divided by 2 minus 5, oops, not 5 minus 2, which is equal to -3, divided by 3, which is equal to -1. So the average rate of change is -1. That tells us something. By the mean value theorem, since it is differentiable, but since it's differentiable here and defined here like this, since I guess this is not a grammatically correct sentence anymore, since the average rate of change equals -1, there must be a value in between. So it must be a value like this, where the instantaneous rate of change evaluated at c is equal to the same thing as the average rate of change. This is the idea of the mean value theorem. This is pretty much the definition. Since we have these two conditions, the average rate of change is equal to a number. There must be a point somewhere between those, I guess, the defined points, where it has that same instantaneous rate. So let's move on to part B. I'm going to erase this all to get all the space needed. Let's look at part B. Show that g prime of 2 equals g prime of 5. Use this to explain why there must be a value k for 2 less than k less than 5 such that g double prime of k is 0. Okay. They're talking about g prime. So let's find the derivative. If g of x is equal to f of x, that's kind of interesting. The derivative of g of x is equal to, using the chain rule, is this. This is the chain rule. Okay, so now let's evaluate it at g prime of 2, which is equal to f prime of f 2 times f prime of 2. That's very interesting. Okay, let's see what we get. F of 2 is 5, so it's really just f prime of 5 times f prime of 2. Okay, and then what? Seems like we're stuck here because we don't know the value of this. So let's continue on. Let's try the derivative of g prime of 5, so let's plug that in here. What do we get? So it's f prime of f equals 5. If we look at this, it's 2. So f prime of 2 times f prime of 5. These two are in fact equal. So we showed, I guess using the chain rule, that they're equal. So therefore, g prime of 2 is equal to g prime of 5. Okay, use this to explain why there must be a value k for that interval such that k is equal to 0. Okay, so this is another application of the mean value theorem. Because the rate of change, or the rate of this rate, so think of this as just a new function now, so think of it as g of 2 and g of 5. Since they're equal to each other, let's say 2 is here, and then 5 is here, and let's say this is the graph, let's say this is the value it corresponds to. Since they're equal to each other, the average rate of change between these 2 points is 0. So that means the rate of the function, or there must be a point in between this value where it has the same thing. So this is basically the same argument. Since the values are equal, the average rate of change between those 2 points is 0. By the mean value theorem, because we can use it because it's twice differentiable, so we can differentiate it again and still get the same result. There must exist a x equals k where this condition holds, such that the average rate across this interval 2, 5, or yeah, 2, 5. Let me write it more clear. Between x equals 2 and 5 must equal 0. The instantaneous rate, which is 0. And that's kind of the justification. Since the values are both 0 and the rate of change, the average rate of change between those points is 0, there must be a value k in between this such that the derivative of the function that we're looking at is 0. And I guess it's very confusing because we're thinking of g primes already being rates, and then we're thinking of g double prime. But just think of it as like taking an extra step up from the mean value theorem. Instead of thinking of f and f prime, we're thinking of g prime and g double prime. And it still holds as long as the conditions are met. So this is the idea with the mean value theorem. Hopefully it made a little bit more sense. We're kind of jumping into more abstract or more numerical and analytical types of problems, not really the graphical ones like we saw in the previous video. So this is kind of like the justification that you would need to show. You need to first prove that the mean value theorem holds true, or you can use it, and then you have to be able to find the average rate of change and prove that there must be a value within that interval where the average rate equals the instantaneous rate.